Okay, so here's just kind of a general solution for the boat and log question from the homework. All right, so what we have is the boat is traveling upstream. Okay, remember I'm a physicist, not an artist. Okay, and so we know it's already traveled a certain distance. Okay, and so it's going to go up the stream and then come back to its original position. We'll call this b equals 0. At this point in time, it meets up with a log heading towards the initial position, okay, where the log will be traveling at a speed of whatever the river is going, right? So the log is not, it's just kind of floating along, okay? And so and we'll call this distance traveled d. We'll call when they meet up, okay, when the log and the boat meet up, we'll call that distance L, which makes the return trip d plus L, okay, because it's going to go back to its original position, okay? And so what does that mean in terms of times? So the time for the log is actually the total time, and so it's going to be travel a distance of d at a speed of the river, okay? Now, the boat going upstream, which coincidentally is actually, this is the time given in the wording of the problem, or in the problem itself, okay? And so that's going to go upstream with at a time of L over VB, so the velocity of the boat minus the velocity of the river, right? Because as you go upstream, right, the river is doing this, coming at you, okay? And so it's actually slowing you down. Now the downstream trip in terms of time would be the total distance, because remember, they're going from the end point back to the initial point. And now the river is going to help the boat, so it's going to be VB plus VR, okay? And now this T here for the log is actually the total time. And so the total time, right, will be the upstream time plus the downstream time, okay? And I'm going to do something here real quick. I'm going to solve this for L, because we're going to use that in our equation. So all we're going to do is multiply VB minus VR over, right? We're just going to take this, do VB minus VR, VB minus VR, okay? So I'm going to get L. This distance here is just going to be the upstream time times the VB minus VR. Remember, the upstream time is the time that was given to us, okay? And so I'm just going to plug in all my equations over here. So I got distance over velocity of the river is equal to, okay, in fact, I can leave this as upstream time, okay, and again, upstream time is given to you, and it's going to be d plus L over VB plus VR, okay? So really now this just turns into an algebra problem, okay? So I'm going to multiply everything by VR times VBR, VB plus VR, okay? Or you can kind of do a VB VR plus VR squared, however you want to do it, right? You can multiply, but what happens is when you do that, you get VB or D times VB plus VR equals, and here I'll do VB VR plus VR squared times T upstream plus, and now I'm going to plug in this L over here, and so things are going to get a little crazy here, so it's going to be D plus time upstream times VB minus VR times the whole thing right? I'm running out of room. This VB VR plus VR squared, okay? And now I'm just going to kind of do all my distribution. So I'm going to get D times VB plus D times VR equals VB VRT plus VR squared T, okay, plus DVB VR plus DVR squared, okay, minus, again, I'm running out of room and I apologize for that. Minus, oh, sorry, in this area, because it's going to, the only thing left here is VR, sorry, because we're going to, when we multiply it, we're going to cancel out the VB plus VR. Sorry about that. So let me go back and, so it's going to change here, right? So we're going to get DVR, okay, plus VB VRT minus VR squared T. Okay, so I know there's a lot of confusing things here, right? But here's some good things that happen. Let me change the color. So I've got a plus VR squared T. I have a minus VR squared T. That goes away. Little SAT trick. If you have the same kind of factor or the same thing on the opposite sides of an equal sign with the same, plus or minus, those go away. Okay, so if I kind of collect things together, over here I have d times the velocity of the boat. Although that should be the velocity. Oh, no, okay. Right, sorry. And then over here we got a VB VRT plus a VB VRT, so that's 2 VB VRT. Okay, and so now look what happens. Goes away, goes away. So I have D equals 2 times VRT, and we're solving for VRT. So it's going to be VRT equals D divided by 2T. Okay, and this D is what's given in the problem, right? And the same thing with that T. So here's how you find the speed of the river, okay, based on, whatever your numbers are. Again, remember, Quest changes the numbers. All right.